Okay, so I'm going to talk a little bit about machine stability. And basically what the point is here is you have a center of gravity as you're working, and you have to keep your center of gravity on your center of stability, or between your points of stability. If your center of gravity, right now my center of gravity is probably right here. If your center of gravity was out here, the machine will flip over. And so your stability is dictated by your center of gravity. So the footprint of this machine, the track frames are about, from this outer edge of the track frame or the trackpad to the other track pads, about 18 feet. But that's not really where the stability is. If you notice, the rollers, the support rollers, sit under here in from the edge of the tracks. This is where your outer edge of stability is at the outer edge of the roller, not the trackpad, because the trackpad can twist. It's not stable. Your stability is right here where the roller meets the trackpad. And also, from front to back, you have these rollers, these bottom support rollers. These are the ones that are sitting on the ground, as these bottom support rollers. Okay, this front idler is not on the ground. If you look, this trackpad is kind of kicked up a little bit because this front idler actually sits about 1 inch higher than these rollers do. So this is the front, the forward end of your point of stability is this roller, not this one. That is not holding any load, and it's the same on the back. On your finals, your final drives do not sit on the ground. They are actually up a little bit, and you can see by the way that this trackpad kicks up right here. The final drive is not actually on the ground. Your actual point of support is right here. So what you can do is you can block your crawlers. And what we mean by blocking the crawler is you put a 1 inch thick piece of metal right under this trackpad, and that will put load on your crawler, on your front idler. And so that's what these blocks of metal are right here. These are my blocks, and I can put one under this track and one under that track and block my crawlers, and that gives you a little bit of extra capacity because it helps your center of gravity. So right now my track frame is 22 feet long, but from this crawler to the rear, or from this support roller to the rear support roller, 16 feet, and from this support roller to the support roller on the other side is also 16 feet. So I have a square 16 feet by 16 feet, and that's what my stability is. Okay, so when I'm sitting in this point here, I have a total of 82,000 pounds of counterweight. 22 here. These are, I think, 6,500 pounds a piece, I think. I can't remember, but I have 6 of these stack weights. The base plate's 22,000, and I've got the two 11,000 pound side weights. But everything together, this stack's 64,000, and these are 22,000. I don't remember now. I know it all together is 82,000. So right now, with my boom stretched way out like that, my center of gravity, like I said, is probably about right here. It's showing on my LMI that I've got a 5,000 pound capacity. If I put 5,000 pounds out on the tip of my boom, that will shift my center of gravity out to here. If I put 6,000 pounds out on the tip of my boom, it's going to shift my center of gravity out to here, and the machine's going to tip over. Okay, now as you rotate, you are rotating a circle, and your boom tip is traveling in a circle, but your pattern of stability is a square. You've got a corner here, and a corner here, and a corner there, and a corner there. So as you rotate, the distance from your center of rotation to your point of stability is greatest over the corner. And so you actually have more stability over the corner than you do off of the side or off the end. Your ground pressure, stability is going to be affected a lot by ground pressure. On this ground here, I know it looks muddy, but it's actually pretty hard. There's solid rock underneath here. Your ground pressure is lowest when you are working off of the side, because you have all of this track on the ground holding weight, and right now, like I said, my center of gravity is back here, and all of this track is holding my center of gravity here. When you're working off of the front end or the back end, you have the highest ground pressure, because you only have these two pieces of track. And so, if I was swung around here, I would only have, my center of gravity would be here, and I would only have these two little bits of track that's holding the whole weight of the machine. And if the ground is not stable, the ground will collapse. So the way that these Sani crawler frames are designed, with having these counterweights on the track frames like this, they are designed to give you greatest stability when you're working off of the side. And that is where your lowest ground pressure is working off of the side. On other brands, Manitoloc's, Cabelco's, Leibherr's, they have counterweights on the car body, and they are really designed for working off of the front or the back. And when you rotate around to the side, where you have the highest, or you have the lowest ground pressure, you don't have the counterweight to work off of the side. If you could imagine looking at this from the top, and as you're rotating around, as you're loading your boom, your center of gravity moves towards the load. And if you keep loading it, you can load it enough to where your center of gravity goes outside of your stability, of your line of stability, and that's when you upset the crane. And so you can actually chart. Some of the newer models have a stability chart that's built into the LMI, and that's what it shows, is what it looks like from up above, and where your center of gravity is as you're loading and as you're moving around. And the Manitoloc style of counterweighting system, like I said, favors the front and rear. And so you get this stability pattern that's a little bit of an elongated oval, whereas this style of counterweighting system favors working off of the sides, and you have a stability pattern that's a little more of a circle rather than an oval. And so this type of counterweighting system is going to be less likely to upset when you move from working off the end to working off of the side. And that's when I think when you look at all the videos on YouTube of cranes upsetting, it seems to me like that's pretty common, as people are at maximum capacity moving from stability to instability. They're moving from a stable position where they pick a load up and then they swing to an unstable position and upset the crane. And I kind of feel like the Sani design, having these counterweights, is going to mitigate some of that. But I know a lot of people that really don't like the Sanis, that they think that they're junk or whatever, and they don't like the counterweight system. I think it's just because just a bias, that people have their favorites. One of the issues that I have with Sani is that when you block your crawlers, they don't have that in the load chart. They don't have that as an option in the load chart. In Manitoloc's, you have a separate load chart with or without counterweight, without your car body weights, and you have a separate load chart for block crawlers. And Sani doesn't give you a load chart for block crawlers, which I think is unfortunate. I think they should. You see how much clearance I've got back here between the back and the wall. It's not very much. I could move this way a couple of feet, and that would be it. I'd be hitting this wall. Anyhow, just a word about crane stability and the things that we have to consider when we're trying to keep these things from tipping over while we're working. Keep your center of gravity over your lines of stability, and that's what it's all about.